All right. Sequence sorter. All right, let's take a look at our story. Seeing is a form of control, and if you can see something for its true essence, you will be so tired, eyes need rest. Okay. This is as far as you've gotten? Uh-oh. Well, hey, you can join in and help out then, right? Because then it's not unless you wait, have you beaten this one? Okay, sequences are zero terminated. Okay. Read a sequence from in. Sort the sequence. Write the sequence to out. Okay, you have not. All right, so now we have to do a sort. So all right. My sorting algorithms are not my specialty. I've memorized a few of them, but that's all in like higher order languages, higher level languages. Yeah, bubble time might be work. I don't really care about the performance, right? We don't have a random, so I can't do BOGO sort. That would be hilarious. Also, Skinnis, hello. How are you doing today? Okay, so we have two stacks, so we can use those to sort of save things. I wonder if I. Okay, so what's the order they want them? We want them in lowest order first, right? So 67, 27, 86, 15 becomes 15, 27, 67, 86. Okay, good to know. Oh no, your save file doesn't carry over from your other. So there is cloud saving, but because I had previous stuff on, I did some shenanigans to like sort of delete all my progress and restart over again. I think I screwed up my cloud stuff. So I'm also like only on this system, and I've been terrified of updating that until after we're done with all the tests. Then I'll try it again. You want to speed run the rest of the game right now? Like the first few levels, that's easy to do. It gets a little bit hard. Bubble sort is the easiest to remember. I think it is, right? Because it's just take a look at what this is. You then move it up. But we have two stacks, so I could. Let's see. Okay, so let's say we take in a number and we just store them in here. So let's just go move up to right, right? Oh, except it's zero terminator, right? So that's gonna be interesting. I have to have some way to tell it to start over again and do it. So if I move up to the right, which I can't do that, I have to do move up to ACC first. Move ACC right. Oh, ad break is starting in 3 minutes. So I'll probably just continue working through that for right now. There's no way I'm gonna get this done in 3 minutes. We're still experimenting with it. So if you get hit by the ads, I will see you on the other side of this. Bubble sort was the plan, but the issue is the figuring out the node layout. Yeah, let's just sort of see. It might be like a bubble sort. I wonder if we would do select sort. I forget some of like how some of them works too. Certainly I'm not going to be doing quick sort. I don't think that's a good idea at all. Okay, so move up to the right, and then if we are greater than 0, jump back to start. And if we're less than 0, so if we're equal to 0, let's move down to ACC, which will just get hit by this, right? So okay, so we have I don't. Okay, so I need to move you here, so I don't have the 0 in here. No, what did I do wrong? Okay, so move up to ACC. Oh, okay, so if you're greater than, oh, yeah, don't. Okay, so if you're What did I do wrong with this? Okay, so move ACC right. Oh, because I can't move that down. Okay, so if we're jump equal to 0, go to end. Otherwise, move you right. Jump to start. And if we're at end, just move down to ACC, which should just be stuck. Yeah, okay, so then that just sits there and idles. And we have all 4 of these in here. Okay, so in the same order that we got them in. Great. Now, what do we want to do? Yeah, Zilby's, you're in the correct spot still. I want to take you out. And we want to take you out, save it, compare it to the next one. So, okay, bubble sort would be, I take this out, let's say to here, and then I save it, take the next one out. So that would be what, 86? Compare it. If you are, I want it in this order that it has. So 15 is the correct order. So I say, hey, 15 is less than 86. So I basically take 15, subtract from 86. If you are less than 0, we just keep your position because you're already less than 86. That's great. And then just go and stuff you in here. Doesn't that just put it in the same order? Otherwise, I put the other one in here. So let's imagine that we just try that a little bit. So if I just say start, move up to ACC, we save it. Oh, but then a problem is as soon as I start mutating this stuff, I lose it, right? So that's not great. So I can either send it back to the stack for safekeeping, or I can move it over here to be just like sent right. So let's just move it right. So move up, right. So move left, the ACC, move ACC left. So now we're going to sub right. Now we get the first one comes out here, right? So that's 15. It's the last one that comes out. We get 15, and I want to subtract from this, which would be 86, and 15 minus 86 would be less than 0. So if you're less than 0, that means we're already like we have smaller. We have small. Otherwise, okay, so we have a small one there. Otherwise, we have large, right? And so if we have a large one already, that means 86 is the next one that we really want to be. I don't see how this is going to work. Because I'm just doing 2 of them, right? So then let's say we just move that back into here. So we move right, left. So let's also move AC left again. This will be move right down. Oh, I do the same trick that I did before. I put it back in here maybe. Maybe I just loop through and I take them out. And they have to have like take a trip around. Is this what you were running into? Like we have to have a little fun trip around the block. And then each time I go through and do this, I swap one of them. I wonder if that would work. Well, hold on. I kind of like the ad idea just because I like the idea of the visuals. I wonder if I'm gonna need the 0 in here. Oh, the out's gonna be interesting. I wonder how we're gonna do that. So if we take this and we want, okay, so let's just shuffle things around and see what happens. So if I do we move left to ACC. Now the last one in here is gonna be a 0, right? So if you're equal to a 0, we go back to start. I just don't want to move. I just don't want you to move in. You're not part of this. So we start and we're done. Otherwise, we're gonna move ACC down. Oh, but I need a count how many there are here. Oh, so almost like I need an init where we're just going to move 0 to ACC and save. That way I have 0 here. Move left to ACC. If you're equal to 0, start. If you're not equal to 0, we're going to swap and add 1 so we can have a count of how many there are. I don't actually know if I need a count for this. That'll be interesting. We then move ACC down. Okay, so then we have to swap again, move ACC down, and then we just have you going all around. So move up, down, move up, left. Okay, so move left up. Now, at this point in time, I do need to figure out when to stop, right? It's like this is gonna be an infinite loop. It's just gonna move things around. It's never gonna end. So I can count how many we have here, but this is not. Oh, look at that. So we never actually get down because it moves through this system so fast. Okay, so that's not okay. So I can't do the move around the ring around it because it happens too fast. I need to slow it down. Okay. Okay, so if I want to, let's see. So, okay, counting this is probably the wrong thing. What if I were to keep the 0 in here and then also the count? Like if I put in, okay, so we throw in you, so all 4 of you, plus the 0, but then after that, the 4 again, that would tell me that there's 4 of them. And I now know that there's 4 of them. So now I'm going to be able to do it just 4 times and that's it. Changing positions of 1 or 2 doesn't necessarily seem that hard. Knowing when we're done feels like that's going to be actually the hardest. We could potentially calculate based upon the length how many times we have to check and do like a bubble, but bubble is n squared, right? And there's no multiplications. I'd have to like set up one of the nodes for multiplications just to figure out, just to calculate how many rounds through we'd have to do. And that would be worst case scenario. We'd just be like moving things around. Ooh, okay. Now, okay, one thing I could do, okay, what if we, let's go back to, let's reset. We throw everything in here, but not the 0, right? So then we stop. Now, for you, I take you out. If I take you out and I want to compare it to everything else. So I know I have 4 things in here. So if I say, hey, I have 4 of you, I compare 15 to 86. 15 is smaller. Great. 86 continues going on into here, and we store it into the stack memory node down here. 15 to 27. 15 is still smaller, so we send the 27 down here. 15 to 67. 67 down here. 15, then we can just, oh, there's no more. We send that out. So I need, okay, I don't know exactly how this is going to work, but based upon that, I absolutely have to have the count of how many are in here. So we're going to do that. We're going to do that counting trick again. So if we start, so we have to have an init here. If we move 0 to ACC and we save that, just so we have our backup of the count, then we're going to move up to ACC. There's always at least one, right? So if we move up to ACC, if you're equal to 0 end, move ACC right, swap, add 1, swap, jump back to start, otherwise go to end, and let's move our count down then. So let's swap, move ACC down, and then we're waiting for something to capture that, and then obviously we can Then we go back to the internet and start over again. Yes, this is moving 4 down. So now we know we have 4 in here. Okay, perfect. So I have the length of our sequence. I need to pull 1 out here, and then we store it. So let's just move up. Move up to ACC. I don't know if we need to keep it multiple times, so I'm just going to go ahead and let it go down slowly over time. So we're going to move ACC right. So that way I can now have that here. So if I move left ACC, if you're equal to 0, we're done. And therefore, I just want to move what we have up, down. So if we're equal to 0, we move to end. Otherwise, we want to take U and we need to compare it to the next one. So we need to take U and save it. So move up to ACC. We need to save U. We need to move up to ACC. Oh, but now I lose it. So if I want to subtract the second one from here, so we need to keep that more permanently. So let's see, I need to, instead of move this, I can save U, but instead of move up to ACC, let's move up right. We're now going to move ACC to the left, back again. So we just store you, we send you over, just send it back to me. And then now I can say, okay, move up right. We're going to sub right. So we had 15 come in here. And then we take 86, put over here, it comes back out. So 15 minus 86. If you're less than 0, I want to, that means that this one was bigger, right? The one I have is bigger. No, the one I have is smaller. So we're going to jump. So if it's less than 0, jump, have small. Otherwise, we have bigger. Okay. Okay, so jump this there, have small. Let's see, I want to then if we have smaller, but we're not done yet because we still have more of these going on, then I want to keep it. So we're going to move it. So I want to swap to get our original 15 back and move ACC probably right. We're keeping you. This sucks because you're right. I don't have enough. The position of the squares is terrible. Oh no. I might have to move it down, but I want to keep this for like knowing that it's just sending stuff out. Oh. I'm gonna have to do some like clever math and like other things in here too. And cleverness and programming, not always the best. Okay, so if I move you here again, this is the smallest. So like we're now moving left to ACC again. And we have the smallest again. So we still have the smallest. Do I actually need to do that? I don't, wait a second. Do I? Hold on. I have the smallest still in back at this point, which means all I want to do is take what we had, take over here, and we want to send it on. I need to send it down to go into the stack memory node. Okay, so I don't send you to the right. I don't swap you. We have small, which means the bigger one we send over here, right? So we're going to say move right down. We're going to move up left to store in there. I wonder if I should move it down here, because like I'm not sure how I'm gonna get the number of these to know that the next one is gonna be it. This is gonna suck. Okay, so move right down. Okay, so if I have small, I don't want to move that down yet. I want to keep this. So we keep that in backup. Oh, wait. So we have small. So this one is actually the other one. The other one. No. Okay, hold on. I want to swap. And then we move ACC down. Oh, that's what it is. Okay. Because we have the larger one at this point in time. So we grab the smaller one out here and send it on into here. Which then we need, I want to take the smaller one and say like, hey, it's on our backup. So then we want to move right to ACC and save it. And then we're done, which means I need to jump back to start. However, if we have small, then I want to move right down first. So we move right. Uh-oh. We just move right down. We don't even bother saving it. We have to swap. Oh no. Oh no. I don't have enough room for it. I was gonna swap and then resave. but this will never send the actual smallest one down, which sucks. So I have to break, this logic is gonna have to be broken out into multiple squares. Oh no. Okay. All right. So this won't work. It's I'd rather, in real life this would work, but we don't have the room for it. Breaking out the nested loop into multiple unit processors, whatever they're called. Yeah, that's I think they're called nodes. Yeah, they're called nodes here. But how am I going to do that? So start is like, this one is pretty bad. This is really big. And so an end, I want to move up, down. So what I'm missing is the ability to do one save, like a save, and then jump back to start. That's the problem. Okay, so you're jumping back to start here. If you're equal to 0, end. And then, okay, so move up to ACC, save. Okay, so what if I take some of this logic and we just throw you over here, like what you're suggesting? So what if I don't move up to ACC? What if I do my comparison by just saying, okay, so just move up, right. So, okay, so this would be interesting. What if we just say we're going to take 2 items from up, right? I want to take 2 items and I move it up. Oh, this is going to be, oh, ooh. So the problem is here, then the next problem is I move left to ACC, and that starts with 4, right? So I have 4 here, and you're greater than 0. But I want to move 2 of them. So if it's still 1, this will deadlock. Because I really want to be able to say, hey, move 1 there. Okay, so if I move upright and then immediately move upright again, so both of them come over here. So we then say you're going to calculate, like return, like take 2, return, like sort and return. Like that's kind of what it's going to be. Take 2, sort, and return. That means you need to return to me if there's more than 2. So I kind of want to just have this be, it's going to have to be smart, intelligent about it. So return 1 if greater than 2 length. Okay, so else we just do 0. So what if I do this? I convert our length to that. Let's kind of like this. I'm gonna shove it down there. You're going to, okay, so if have greater than 2, really greater than equal to 2, move to right to sort. So move to right, that sorts and returns. We have greater than 2, so we're not at the end yet. I need to move them down here, don't I? I need to get them into this stack in that order. Otherwise, we're never going to touch these ones and even look at them. Is that the right idea for this? Or do I want to completely look around and like just do like a big bubble sort like all throughout that way in here? It's like something that just came to my mind. What if we start our sort here? Like before we even get into our stack. What if we even ignore the stacks? Can we do that? Can we just basically ignore the stacks and we'll say like, okay, we take you, we throw you into ACC. If you're less than 0, then do the comparison. The only problem is like we need to do comparisons are expensive, like space wise for code. I don't like it. Anything next to the stack can use the stack as memory, which is interesting. And then that would like move into here that like just pulls 2 from the stack, right? So like we pull 2 up. And then we just say, okay, comparison, all right, and then return them in the correct order out to here. Oh, but then that's the next problem, because if those 2 are now the correct order, they're always in the correct order. I really need to compare them to the other ones. So yeah, that won't work. That would be interesting, but I still need to do the, hey, first compare to all of you and then put into the correct position. So yeah, that won't work. So okay. I wonder, do we want to do following based upon like the previous one that we did where we just threw everything into the stack? I guess that's what this is, right? This is we take out, I take out 1. Okay, so what if we do just take 1, save. After we take 1 and save, we want to compare all others. Compare to others. I can't use. Oh, interesting. I can't put anything on this last line. That's sad. Okay. We compare to the others. If whatever. Oh. Yeah, so this would sort of, okay, wait, this would sort of be like is this bubble sort? Is this like reverse bubble sort? Whatever's the smallest one, right? So like then if you're still the smallest, okay, by the time we're done to the end, I don't have to compare. We just compare to, we sort and return the last one. So get save other return small. Does writing algorithm a familiar programming language, but by carefully limiting variables and translating the assembly help? I don't know if it would, because there's a lot of abstractions that I end up using, and the like loops are weird here. If maybe doing it in assembly outside of it would help a lot. I don't know. I haven't tried that though. But okay, so if I just do this, if we basically store everything into here, we want to take one out and save it to here, right? So then we save it, and then we send like another one, and then you take, basically you're not just taking 2 in, you in like take number, you're going to save it, you're going to compare all other, swap if small, return other, at the end of it, return small. So if we have 15 here, so we grab 15 down, it's the first one out of the stack, we store it away. Then we grab 86 and we say, hey, compare it. It might do the comparison like up here. And it says, oh, here's the one back that you want. So it returns 86 back to here and 15 gets saved. 27 comes down. Oh, then 86 comes down here and then or whatever, gets sent back to here. $27 comes down, compare. 27 comes back out into stack memory. 67 comes down, 67 comes out, and then 15 comes out and just straight down. And then we're done with that. And so then we need to clean up and resend everything back into here, and then do the entire thing again, but now knowing that there's 3 of them instead of 4. And then again with 2 of them instead of 3. And then 1 of them because there's 1. That feels like, that's not bubble sort. Because bubble sort just moves it up 1 and it bubbles up to the top. This is this select sort? That feels like select sort. But it's been long enough that I forget the exact definition of select. There's another one too, right? I forget the various sorts. Okay, so let's... Okay, so if we start here, we're going to take one and save. So I need to be aware of how many we have left to do. Oh, insertion sort. Oh yeah, I forgot about insertion sort. Definitely not the merge sort. Right, merge is like take 2 halves of it, right? And then do something and then put it back together. I forgot. It's been 3 years since I've done any sorting algorithms myself, but actually it's been 4 years since I've done any like I was teaching computer science stuff, and I've forgotten everything. I think it's selection. That makes more sense. Oh, you know what? Okay, the difference between select and insert is in place or not, right? Select is putting it into a new one, and then insert is inserting it back into like the same array, the same. Yeah, I think that's what it is. And I don't need to put it into the same array. We can just return it as we figure out which one is the smaller one. So therefore, select is probably the best way to go here. Okay. So how do I know how many that we, okay, so we now have our count here. So we have the 4 that we have here. We have the 4 that we have. So we have our length. We have our length now here. I need to get the length. Coffee, hello. How are you doing today? So no matter what, I need to get the length, and I need to check to see if we're equal to 0, our length is 0 now, and we're done, right? If our length is equal to 0, we're done. We're gonna have little space, so I'm just gonna start with the small space version. Okay, so we move left ACC and then jump to here. So then what this is you just got back from work, so you're pretty tired working. And HQ is 3 times more stressful than working. Oh yeah, I know exactly what that's like. Yeah, working from the office is good, but it's also way more tiring. But my company, the company I work for right now, doesn't even have an office anymore. So there is no more office for me in my near future. Okay, so if we move up to ACC, I don't know if we need to save this. So let's, we'll move ACC to right. So we have length of 4, and then I want to sub 1 so that the next time it's going to be length of 3, right? So then this goes back. Oh, but I don't want to go back up to start. So you sub 1, and then we want to jump. Okay, so if we're equal to 0, then no, because I need to set this up to if it's equal to 0. So if we're less than 0, if we are greater than 0, okay, so if we're less than 0, go back up to start. If we're greater than 0, maybe I sub 1 ahead of time. Move up to ACC, sub 1, move ACC to the right. if we're greater than 0, I want to have a run. Otherwise, we go back up to start again. And so that's what happens here. Oh, awesome. Great job, Albert. You're on 1 out of 5 days at headquarters, 4 out of 5 days at home, which is nice. You know, that is nice. Yeah. Do you get to choose which day to go into the office? Yeah, you make your day around talking to other people. That's exactly what I did. When I went into the office, that was my social day. That's where, you know, it was less about getting work done and more about socializing, networking, politicking, you know, all of that good fun stuff. Planning, that kind of stuff. Okay, so then this will slowly reduce down. Okay, so if we're doing nothing else, then we can see so we're moving 59 down. Why? Oh no, you put 2 series of numbers in here. That's not good. Okay, so I don't want to go. So I need to wait until I get some message back that everything is done in order for us to know that we're good to go here, right? So if we move right, I can't move right. Well, no, okay, so we're done here, right? So if we move right to ACC, and if we're like, let's say equal to greater than 0, oh, what if I do that fun stuff? Let's jump relative ACC. So if I put like -1 into here, it just tries it again until eventually I tell it, okay, go back up. Just do 1 down. Or like 0, where it just goes down. I don't know. So if we do that, I still did the entire thing again, which is not what I wanted. So I move up to ACC, then we subrun, we move ACC right. If we're greater than 0, run. Yeah, shouldn't that... I have 3, but that's the wrong one. Huh. You're allowed to choose your day, but there's the day where most people work. Okay, yeah. I mean, yeah, that happened to me too. It ended up being Wednesday when Friday would have been my best day. But it's the sometimes, you know, we give it up for the team. Okay, so someone why are you doing 2? You're moving, okay, so we have init, so we move 0 to ACC when we save that. We move up to ACC. If we're equal to 0, we go to end. Otherwise, we move ACC to the right. Swap, add 1, swap, jump to start. Okay, so then if we're equal to 0, we end, we swap, move ACC down, which then catches it and then goes back up to init again. Oh no, so I have to wait until move down to ACC and then, okay, so we could do the same thing where we can jump, move down ACC, jump relative to Jero, ACC. So we Jero ACC, so if it's down 1, then this is going to be move 1 up, and then that'll be down here. So we just want this to jump 1 down, essentially. So either I send a -1 or a 1. So you, there we go. Okay, so now this is waiting for you to return, hey, we're done, and we're ready to get the next grouping in here. So now we have these 4, and then you're getting 3 here. So that's good. I want to take a number out. And then move it to the right. So we're going to move. Okay, so we have to move left to ACC. If you're greater than 0, so jump, I guess like, okay, wait, if you're less than 0, jump to end. Otherwise, we're going to continue. So we're going to move up to right. So we'll just start with that, right? And then end is we're just going to move, I think it's just move up, down, because like whatever the last one is, we just move it down. Okay, so here's our 15. I want to take this 15 and we want to store it away so that we can start comparing it. So I'm going to be doing this a lot where we're just sort of checking through, doing one line at a time. We're just trying to break it down and keep the changes to a bare minimum to try to like not overwhelm ourselves with like complexity and like overthinking it. So we're going to move left to ACC. So now we're going to have, we have both of them here because you moved both of them, and it got immediately overwritten. So it had 15 and then it immediately got 27 and then it's waiting again. Okay, so we have the 15 and then I need to store that away. So we save it. I then want to probably move. So move left to up. So we're going to move this back down again. So now we're going to sub up. And now we can compare. Okay, so if you were the smaller one, you'll be negative. So if you're less than 0, we have small. Otherwise, we don't have small. We have large. And so if we have large, this is the large one, and we want to resave this, which means that we want to send this one down. Now, there's a lot of swapping that we can potentially do here, but I'm not using this. So what if I move left to ACC, Okay, so I moved, instead of saving, what if I just move ACC down? Okay, so this is our large. Is that right? No, this is just 1 and 2. That's all it really is. So I move, so left it goes to ACC, and then we move that down. So this is 1. Then we move left, so that's 2. Then I sub U. If you're less than 0, then the second one, if we're less than 0, then the first one is smaller. So this is smaller. If we're not less than 0, that means the up is smaller. So then we're going to move up, left, and we're going to keep this one here. So then let's move down ACC, and then we're storing that. We keep this as the smallest all the time. So move down to ACC. Okay, so we're down here. For you, we have the small, so I want to move up. I did this wrong. Oh, let's rename this. It's not have small anymore. It's now down small. Okay, so down is small. So we moved up and to the left, moved down to that. But wait a second. Okay, so hold on. So sub up, down is small. If small is this one, I want to move up left. So this is actually, I want to move down is small. Down is large. So we'll move down left, move up to ACC. Otherwise, I want to move up left, move down ACC. Now we get to here, and we want to reset. So I want to move. Oh, okay, I want to reset. Oh, advertisement started. It's been another hour already. Oh wow, it's 11:30 already. Okay, I'm gonna take a quick break, and then we'll come back and continue this on. So I think I know where we are. I want to reset this by moving this thing down. But let's go ahead and mark us as a break, which I think I have it as Zilby large, right? I don't have a Zilby large in my. We'll do cat large. 3-minute break. Okay, I will be right back, and we'll see you shortly. All right, we're coming back. Let me reset. Let's see, I want to go back to here. Okay. All right, I think we're still on the right track. Okay, so I've now moved everything up to AC. Let's now move ACC down. So at the end of all of this, down is where we have our smallest thing. So we know we have that. And then this comes back up to start. So now I only want to take 2 the first time. Oh, wait, maybe I just move. Oh, do I just not care? Do I never save 1? my initial thought was I keep one over here and then I just keep on passing other ones and it compares them forever. If I pass them both back in that order, and then I can just take another one and send it over here, and I don't need to do this reset at all. Then we have like just down small, and so we just move. It's just the order that we move them to here. So I moved, if down is smaller, I moved up left first, and then I move down left. And then we're going to jump to start. And if down is smaller, we're going to move down left. But what's the order that I'm running this? I'm terrible at this. I'm terrible at this. Okay, no, I want to do. Okay, if down is smaller, we want to send the less small one. So up left. If which is this, which is up. So move up left. Otherwise, up is smaller, so we're gonna do down left, up left. Otherwise, up left, down left. Okay. And then we go back to start again. And then we reset that. Okay. So anyways. Oh, fun. All right. So all right. So what happened? Did it? Okay, so I have 15 stored here, and did I lose the 86 already? Oh, it's down here. Oh, okay, hold on. I don't think we're ready to test it yet. Okay, so this compares two numbers together, and then gives me whatever is the smallest one. So if we get, okay, so we move left into our ACC, and if we're at 0, we're ending, which means that whatever we have up here is we're done. But I think that actually may be wrong. Okay, so if we're not ending, so we're not equal, we haven't done it, we still have 4 left here. That means I want to take a number and shift it over to the right. And then we're going to take another number and shift it over to the right. Are these always even? No, they're not always even. Okay. That makes it so I can't do 2 at a time. So I move up and to the right. Do I want to keep the count of how many we have? So if I move 1 to ACC, we've been, okay, so I have 3 in here. So I move up and to the right. Now I really do have 3 in here. I then want to sub 1. So now we have 2 here and 3 up here. and then we're going to move if we're equal to 0, pre-end. I don't think that's a good idea. But okay. Oh, yeah. So we get our count. So how many are in here? Off by 1. We get our, okay, so equal to 0. We end. So if you're 0 here, we have 1 up here still. And we just send it on down. So move up, down. If we're not 0, we move a second one over to the right. We move up and to the right, and we sub 1. And so if we're equal to 0 now, we still have 1 up here, though, then. I don't know if I want to do it. I'm pretty sure I'm going to run into a deadlock at some point if I don't check for 0, if I don't check how many we have after we move, before we move the second one. Unless I do some shenanigans with this over here, where I like send it 1 and if I send it how many we have left, it could then just say, hey, do I want to do that calculation or not? I don't know if I like that. Pre-end is a very question mark thing to do here. Pre-end here would be, I want to maybe move right down, or like we just move 2 down. I'm not sure. Maybe there's no pre-end. Maybe we're just back to end again. Oh no, pre-end, I just like move the largest number we possibly can to the right, so that way it would get back. We would then, okay, so we'd have 2 over here. We're going to move right to nil. And then we move into end. And then this would be move right down. Okay, that handles the off by 1 error then. Okay, if we're not in pre-end, so we have more than 2 total, then I want, okay, so we moved 1 up to the right. We do that. Okay, so we're gonna move up, right. I don't know if we need to sub 1 again. I think, okay, so we move a second one over here, and then we're gonna get the 2 out. And so the first one we get, I want to send to store. So if I like move right, shoot, this is gonna suck. Let's just move it down. We'll move right down. and then restart again. But I don't want to go all the way to the start. I want to go to like back up to here. It's like, oh, jump relative negative like 1, 2, 3, 4, 5, 6. So if I were to do that, what happened? I have 27, 67, so I have 2 missing. So 15 and 86 are here. And hold on, my that Friday job sent me a message. I need to respond. Okay, but not an emergency, just a request for a meeting on Friday. Okay, so oh, I need to. Okay, wait a second. I move this up, so I move left up, sub up. Okay, so I'm 1 up, 2 down. Okay, so I need 2. I do it twice. So move. Okay, so ACC is here. ACC is here. 86 is here. 15 is lost. It's trying to come back up to here, but we never got it. So let's see. We figured out that down was smaller. So let's oh, there's a breakpoint that we can do. So I can do something like that. Okay, so I move up and to the left. So that's our first 86. Goes out to the left. I'm going to move right down. I move down. Oh, I want to move down left. That's our problem. Okay. But now you're looking for up and to the right because I didn't grab right twice. Okay, so we move right down. Right. Okay, so I don't do anything with the second number that I get. I wonder if I do want to store it here. But that's my problem. Way back and forth. All right. They're telling me about things that I'm gonna be talking about at the stand-up on Friday, which I'm not worried about at all. I'll just like, okay, just I'll find out on a Friday. Okay, so do I want to just store it here permanently? I don't. This is almost like then the first time, like the init, we take 2 out and we shove them in here, but then after that, it's just 1 at a time. And we just keep on going, and at the very end, after we're done, we take this one back out. That might be easier. We can do that with our JRO. So we have our basically we have our start where I moved. Okay, so we get our initial counter. Let's imagine that I don't sub 1, right? I just take the original thing, so it's 4. So I move ACC to the right. And so we get 4, okay. So we get 4 in here. I probably want to save it. I don't know. Maybe I don't. So I move left or ACC. If it's 0, okay, so I actually, yeah, okay, so if it's 0, we're ending. So what if we don't have start, save a little bit of space? Or rather, we just do that. Move left ACC. And then we'll have like a run. So if this is 0, we end. Otherwise, we are going, okay, so in start, we also know it's going to have to be greater than 0. So we're going to move up and right. So we send our initial one over to here. Then we move into our loop. If we're equal to 0, we end the loop, so we're going to break out of it. Otherwise, we're going to move another one up and to the right. We're going to sub 1, so I should probably sub 1 here too. So we now move a second one to the right. We sub 1. Now we're going to get 1 back, which is the largest one. So we're going to get 1 back, which is the larger one. So I just want to move that down and deal with it later. So this will then move up and to the left. And then we keep that there, and then we go back around to the loop again, right? So then we just jump back to loop. And then when we hit the end, I want to move right down. because everything else has been moved down for that. So if I just do this, we should have, it should be the same thing with 15 at the top, like nothing should happen. Okay, so we need to update you to now store the 15. So you're gonna move left to ACC, ACC down, move. I kind of feel like we need our init too. So maybe, okay, maybe we start with, okay, we have a start. So move left to ACC. So this is the first one that we get, right? And oh, it becomes by default our smallest one because it's the first one we've seen. So we just straight up move it down. And then we're going to have our run. Now we're going to move left. We just move the next one to be in the up position. Now I want to sub up if you're less than 0. Down is still the smallest one. And therefore, nothing really changes. Down stays down there. So, okay, if you don't jump, that means up is bigger, which means I want to move down to the left. I want to move up, down. And then we go back to run again. If down is the smallest one, nothing happens really, right? I want to move, so move down to nil because I don't want to actually lose it. So I have to do something with it. And then move up, left. And then this, we jump back to run. And then that's it, maybe? Okay, so 15 remains in here because it's the smallest one. And then we have 86 and 27. Okay, good. Now, you're stuck on moving right down. So you're waiting for right down. You're moving down to nil because down was still smallest. Oh, and you're trying to move. Do I need to move you 3 times? So hold on. So 1, 2 for up. 1, 2 for down. No, that's right. Oh, but this entire like move up to ACC. Oh, interesting. Because once I move these 2 up, can I do something silly? Can I just move down? Oh, I can't do that. Okay. So I can move down to ACC. Move ACC down. Why are you trying to jump that back up again? I want to basically have it like store that over and over again. Okay, what's happening with this? Let's step through it. Okay, so we store all of our 3. What's the, let me take a look at the, is there keyboard shortcuts for step to next? Oh no, I have like navigate to adjacent execution node, but there's no like step, there's no debuggers for like step. Oh, but maybe I can use a breakpoint. Maybe we can say, okay, so once we get into run, let's breakpoint there. Okay, so I moved left. Okay, we're waiting to move left to up, and so we have 4 in here. Okay, so 86 goes out, which is that first no, the 15 has already been stored. Okay. So second number comes in there. We then sub up. That becomes -71. We're less than 0, so down is smaller. So we move down to ACC. So 15. Oh, I then want to move. I wonder if I don't need this second move then. I want to move ACC back down. And that's it. Something like that. Now, okay, so now I want to move left back up again. And you're trying to move down to ACC. Do I just need this? No, I feel like, okay, so we sub up and then we move up sometime. So that's fine. Okay, so now move down to ACC when you're trying. Oh wait, that was just the run. Okay. Well, there we go. Okay, so we now successfully get through the first series, and we have 15. So we successfully now have 15 going through here. Okay, so yeah, we have our end, and now we're trying to move right down. Oh, and you're trying to move left up because we're done. Ooh, do I need to store the count here of like how many we're doing? That way, once we get to 0, we now know to send you out. I think I might need to. So we move left to ACC. So then before we even do this, we have to move ACC right. So start, we move left to ACC, and then we have to save it. and that's our count. Okay. So we move our length to ACC, and we save it so we have in our backup. And then we have to move left to ACC again, and now the rest of the stuff can start working and doing its thing. But every single time we run and go, every time we take another one, I'm going to have to sub 1 and if we're less than 0 or if we're equal to 0, and now we're running into this problem again. Now we're out of space. Oh, and I can't sub 1 because I have to swap first. I have to swap then sub 1. So that's way too much time. That's way too much space. I don't like it. I guess what I could do is at the end of this, at the beginning of move, because okay, regardless if we jump, okay, so before we jump to run, we jump to end, and on end we move down left. We just say like, hey, are we done? Do you need the lowest one here? Okay, and so for end, if we're not end, if we jump to loop, so then before we jump to loop, at this point, I want to move right to nil because I don't care about that. And then we jump back up to here. So if I do that, that's looking for the wrong thing. I don't want to jump to run. I want to always move. Okay, so I jump to end, we do this, and then we jump to run down here. You're trying to move right down. You're trying to move down to AC. Oh, do we need to go back to up again? No, because move down to AC. Move ACC down. Wait, do I not need to do this anymore? So if down is smaller, I don't need to do any shenanigans here where I like restore it because you already are smaller. Wait, so wait, if down is smaller, I just literally do nothing at all. If down is smaller, I'm just skipping this and I would just go to the end. And we just do that. No, wait a second. Yeah, no, I still, okay, hold on. Nope, wrong. I want to move, if down is smaller, we're going to move up, left. And then we're going to move this, but we're going to store it. We're going to keep it down there. So we don't move ACC down like that. Then we move into end, so we move down left and we jump back to run. I'm still moving 15 out when I want to keep it. Oh, right, because it's the first, wait, this was the first one that came out. 86 was the second. Okay, so hold on. I've got my logic backwards. So I move left up. I sub up. Okay, so this will be the easiest one. Let's there, we got everything in here. So now I can step through. Okay, so 15 comes in here. 15 goes down. We then move 86 up. I sub up. You get negative 71, so you're less than 0. Oh, so yeah, I don't want to go. Oh, yeah. So wait a second. I need the opposite logic here. So if you're greater than 0, oh wait, no. I less than 0, we go to DS. Okay. So now what happened? Okay, so we got negative 71. So we moved, we're down is smaller, so we move up and to the left. Then we move down and to the left. That moves right to nil. Okay, so we drop you. We jump back to loop. We move up to the right, so that's 27. That moves left up. We move it back down to here, so we sub. Oh, I need to reset this. Okay, so we have our ACC, so if our end, so we move, as part of end, I need to move down to ACC first. And then I need to save, and then move ACC left. Okay, so move down to ACC. Oh, but now I need to do this twice, don't I? So move AC up 3 times? Okay, and you're now trying to move left up. Okay, so I've successfully done this. That's great. Let's throw a breakpoint on start. So every time we it breaks there. Okay. I guess we never go back up to start, do we? Except on end, which I don't think this did properly. I thought that would have gone... Oh no, it jumps back to run again. Well, that's a problem. We never know to begin again. That's gonna suck. Okay, so there's 15 down, 86 up. 86 is larger, so that goes left first. We move 15 into there. I guess I don't need to save it, do I? There's no point in saving it. But okay, so I move you to the left, and so save is here. It's nilled. We jump back up to that loop. We still have 2 in there, so we move up and to the right. 67. No, that was 27 is next. That goes up. We then sub 27, -12. So ours is still smaller. We move up and to the left, so 27 goes down. Jump back up to the loop again. Move up and to the right. So that's 67. Okay, 67 to the top. -52. Okay, so we're gonna move right down. Okay, so that comes down like that. Move down to AC. Okay, yep. So reset. We save. Then we move that 15. Okay, so here's the problem. We're at the last one here. We have no more. Now I'm gonna drop this 15 when really I want to store it. We time to send it out again. So if you are jump ooh, what do I want to do this as? Okay, so we're gonna jump if you're equal to 0, we are time to end. So we go to end. Otherwise, we continue on with this. And so then the 15 will end up here. Yeah, okay, so 15 ends up here. And so what I really need to do, though, is keep our counts down here to know when we have 4, when it gets down to 0, send that one out. So we move left ACC for our count. Before we move up right, we now need to move ACC down. So this is our count, right? Let's go ahead and save it so we know that there's 4 of them. Then we go into run mode. And in run mode, we just move up and to the left, right? We move up and to the left, but then we're going to sub 1. If we're now equal to 0, we jump to end. Otherwise, I guess like, okay, so if we're greater than 0, go back to run. Otherwise, we're done, which means that it's time to move up, down. And then we go back up to start. Kind of. It's a little bit weird. So 15 should go out. 4 went out. That's not what I wanted. Oh, we started with up. Oh, okay. Okay, so 4 went there, 4 went down. So we save you. And now we're going to start. It's like 86 goes in there. Sub 1. For greater than 0, go back to run. Okay, 2. Okay, so this one's on 0. And you're attempting to send the 15 down, which means that I'm off by 1 here. And I'm attempting to move this to the left, and I did not want to move that to the left. So we're going to save you. So let's just do an immediate sub 1 here. And okay, there we go. We got 15. We've got the smallest number now of the first set. Okay, excellent. Now to reset and do it all over again, which I'm not exactly how sure we're going to do, because now all of our numbers are down here in this stack, and I need to either get it to like start doing it from here, or I need to somehow reset this to throw them back into the stack again and then start it over again, but with -1 length. How do I do that? Last time we had enough space. We can like do a reset. Here I'm not so sure. So if we're at reset, so we just moved up down. So let's imagine that we're at reset here. I want to just take you and then move you up. I don't have much room here. Yeah, not having some registers or a RAM-like thing is difficult. I know. If I had RAM where I can just look up in an object and just like store in memory location 1, 2, 3, 4, that'd be great. Or if I could have a stack but not have it set to this location in the node, that, because I think having a stack, all I need is 2 stacks, or maybe even 1 stack. I need 2 stacks. Having them outside of the node system would be really nice. Like if I could have a stack inside of here, or put logic inside of here, that would change everything. But of course, we don't have that, so we have to work with what we have. Theoretically, the game is solvable. Like, you know, I believe that Zachtronics doesn't make games that you can't actually beat. So clearly, there's a way for us to do this. Now, if we're in reset, we can just, I want to take whatever we have. So we have to now swap to get our backup here, which was 3, right? We're going to save. We're going to move left to up. We're going to sub 1 and jump to reset. And then jump if greater than 0 to reset. Otherwise, it goes back up to start. Well, it's already been another hour? Oh, crazy. Okay, so if we're end, we moved right down, and now we're in reset mode, which means I need to... We never saved, so I don't know how many we're doing. It's like we need to do this as the same loop here. I don't have room. Like I don't have room to go up here either, because this is counting how many we did. Ooh. I see where the problem is. Yeah, Vivex, like we're running out of squares. This one's tough. So I'm working under the assumption that I have to get them back into here again. Is that true? Like, is that a true assumption? Can I just use it in here? I don't think I can restore them in here, can I? In the previous one, we did our indexes. We got the index of something. But I did use that reset. Oh, I probably don't want this thing here. Not anymore. So if I don't reset, we have our stack -1 here. Okay, so the assumption I've been making is that I have to go from this stack to this stack. It kind of makes sense that I do. But I've also been assuming that this is the node that has to deal with get out of here. So I don't have much room in here. What if I were to... We store everything in here, and then we could just go back and forth this way. maybe that would work, where I could then say, okay, like throw everything in here and then take out one, throw it in here. Okay, so we just got a quick ad break. I'm gonna do a super quick break myself. Just go like step around the room for a little bit, and then we'll be right back. So less than 3-minute break probably. I will be right back. All right. If we get if I were to store everything in here, and then we take it out, and we do sort of like the entire thing we're planning to do here, but we store in, and then we just sort of push back down again. And then we push back up, and then down, and then up, and then down. And then each way we're going through, it becomes shorter and shorter and shorter. I can't imagine that's going to work. I feel like that's too much for this stack of nodes. But each one through, we just send one to the right. I can't do something like quicksort because there's no such thing as recursion here, right? I mean, there's no functions. There's I mean, I guess like everything is kind of recursive because I'm just sending it back to itself here. But like there's no parameters, there's nothing else. I can't split and send more than one thing at a time. So that's out. This is the first one where I'm tempted to research and look up how like select sort works in assembly, like an example assembly select sort, and then just see whether or not that would work for us out here. But that also feels like cheating. Also, I have no idea if that would work even because we're also restricted by these nodes, and that changes things around a little bit. Do you have any ideas? I'm sort of like in that like, oh, I don't know, and I'm kind of blocked mentally. I don't think this reset is going to work. We don't have the code for it. This went down to here. I don't think I have the I don't think I have the code to even reset straight up here, because you don't have much space. To like re-throw these in here. Because this is just move up ACC. I mean, I could basically have something where it's move up or from down to ACC. I have 2 lines that I could add up here. So that would be a simple if statement, essentially. The straightforward solution translation won't be optimal, so at least optimization will be challenging and complete. Yeah, that would make it a lot harder. Well, so here's my thoughts. If we can't make any progress on this, or at least what feels like progress, before the next ad breaks, that gives us 1 hour to try to figure out something. We might have to end it, and I would hate to do this, but then I'll probably off stream look at some. I mean, it would probably be ending. We could also. We could also look at the last one, because like I can see all of these 2 programs. We can try this one too, and then we can come back to you. Yeah, so I don't know. Like part of me is thinking maybe we just give up on this right now, and then I'll just look it up later, and then we could do a video. I could add like an addendum to the video of like, here's how to solve it based upon like what we learned. Because I'm not sure I want. I don't know. I don't know where we're going with this one. I'm like kind of stuck in like feeling we have to start over again with this specific puzzle. Yeah, that's not good. I also feel we're really close, but I don't see a way forward. So, because of that, let's jump in and try the last puzzle. I did a Google search and found on Reddit someone who solved sequence sorter. And so I put that into our Untitled Program 2 for this. Oh, Blah, you're getting some stream issues? What are the issues? I am not, let's see, I'm seeing 3,000 kilobits per second going up, green, no drop frames. So on my side, OBS says everything is fine. Huh, interesting. Well, Blah, if it's still going bad, I have the YouTube stream up. That it might be better there if Twitch is being. I know that sometimes like Twitch has problems in different regions too, where like everything will be fine in one region and then just be complete not fine everywhere else, or vice versa, like fine everywhere but not in one region. All right, so. Okay, and Rug stream is working for you, so that's good. All right, so the very first sequence sorter that I found was this one, which I don't know how they're gonna feel about me. Probably won't ever find out that I'm sharing this out. This is gonna be fine. But the title is "Wow, I'm Such a Hack," but I stayed with it anyways because it works, and I think working is fine. That's the goal of any of these things, right? So without any, we're going to go through the code and just sort of like see how we could have maybe done it, or just how this works in general, because we couldn't figure it out. And a hacky solution is better than no solution. So that's what we're going with. So this is what we got. So let's see what we got here. Now, if you remember, this solution is all about sorting the sequence. The idea is that we're going to take in zero indexed numbers on the left here. Zero index, zero ended sequence. So basically, here's like an array of like 67, 27, 86, 15, and then 0 marks the end. And then for out, we need to have like 15, 27, 67, 86. So it needs to be in order. We need to sort them, and then 0 end the sequence. Now, I was able to sort the very first one, and then it dies. Or maybe not even the first one. And then I didn't get the 0 either. It was bad. We didn't even come close. So this one works completely. So let's go over and take a look at what it's doing. So in our first box here, we have, and if you're not familiar with TAS 100, this is a game. It's a Zachtronics game. It's available on Steam. It's actually pretty cheap. It's like $7 or so. And you can play it by writing assembly code, and each puzzle level is made up of multiple nodes that you can write. They can't scroll on them, so this is as much as you get, and it's assembly code that we write in here. And we have a stack. We have 2 stack memory codes, and that basically a stack is exactly what you think it is. You put something in, and then it stores it, and then the most recent one you can pop off. So exactly. Assembly. I wrote in here with my sort of labels. The one in a link has different labels in there, but these ones make sense to me. So okay, anyways, we start. So we move up into our accumulator. We're moving that accumulator down. So for example, we get 67 in here, and then we move that down, but we also store it in here. We jump into our loop immediately. We then move right to ACC. So move whatever's in here into our ACC. So let's double check to make sure I got this right first. And yes, I did it correctly. Okay. So we jump into, okay, so if you're equal to 0, we jump into loop, right? But this is not equal to 0 because this is 67. So instead we swap. So the 67 now comes here to backup, and backup, which is 0, is now ACC, and we add 1. And then we jump to end. And in end, all we do is swap them. So the 1 comes down to here and is 67 back again. And then we go back up to start again. So if we step through this, we can see that happening. So 67 goes into ACC. We move that down to down here. Are we equal? Is this equal to 0? No, it's not. Swap it, add 1 to that, jump to end, swap it again, and then back up to here again. And it's going to keep on doing this. So we can see we're just moving everything down until it's equal to 0. As soon as it becomes 0, we say, okay, hey, we're done with this, right? It's time to end the loop. So we jump into loop, which is now we're going to move right to ACC. So whatever is over here into ACC. And now it's going to wait for that. And then as soon as it finds it, we're going to move ACC down and then just if you're not 0, continue on to the loop. So we're going to empty out whatever's in the stack memory trace. So that's all and good, but something needs to go inside of here. And that's what happens with the rest of it. So if we take a look up, the next block that we have here is this, the down up labels. So basically we're going to move ACC to down. So whatever that is. Now that starts with 0, right? So we're going to move 0 down to here. And then we're going to move up to ACC. So if you remember, if this, whatever this is that we got up here, we move it on down. So in this case, it's going to be that 67. And then we're going to jump, if it's not 0, to down again. So we're going to, loop this, but it is not 0. So therefore, we're going to continue moving things down into it. And as you can see, we are basically just taking this entire series of numbers and throw it in here in the order that they're coming in, including that, starting with that 0. Okay, so this is great. Now, in the meantime, these are waiting. So they're not deadlocked, but they are locked because they're this one's saying, hey, we need to move left into ACC, and this one is move left into ACC, and this one is move down into ACC. So these are each waiting for something to be available to move into it, and none of them have anything in it. So they're just on hold right now. So we'll wait until the sequence is finished, and we get the first 0 coming in down, which is starting now. So we have this 0 here. Swap, add 1, jump to end, swap, move up, down, move ACC down. Okay, so here's that 0 that moves down. We move that into ACC. If you're not 0, go back to down. So we are 0, so it's going to now continue to the up one. So move down ACC. So now we're going to start moving from down back up again. So we're going to drain you and move it to the right. So instead of going back up, it's going to come here and go to the right again. So move ACC. So 15, we popped off this stack. We're going to move it to the right. Here it is, which means that we can finally now work on this here. So on this box, we're going to move left in ACC. So we have that 15, which is the very last item in here. We're going to say, hey, if you're equal to 0, move to end. But we're not equal to 0. So instead, we're going to save it. And save it just means ACC and backup becomes whatever ACC is. Okay, pass. Now we're going to move into this label. Move left to ACC, so just keep on doing it. So that's going to be the next one, right? So 86 was the next one popped off. If you're equal to 0, move on to the 0, but you're not equal to 0. So you move on, move ACC right. So move 86, so the second one, over to the right. Move, and now, let's see, move ACC right, that's fine. Now now we have sort of asynchronous code happening here, because like everything is sort of going on at the same time. What's going to happen here is that it's going to swap it, so 86 and 15, and then it's going to move ACC right and ACC right, which means that's going to be 15 right twice. And then it's going to say, hey, I want right back to ACC. So basically, we're doing a little swap-a-roo between these two. Now over here, we move left into ACC. If you're equal to 0, we jump to 0. However, this is not equal to 0. So we're going to save it, just like we did over here. We're going to sub left. So that's going to, this is about to put the 15 up here and then send it to the right, right? So it's going to sub left, and then if you're less than 0, we move on to bigger, because that means that we have the bigger one. So let's see this. So we save use 86 both places. If you're less than 0, we sub left, so that becomes 71 minus the 15. If we're less than 0, we got bigger. We are not less than 0, so we're going to move on to smaller. So we're going to move left. That's this move ACC right. Move left, left. So we're going to take this and move it straight back to here. So that's the 15 right back over here. Now this saves it, so we keep the 15. And meanwhile, over you're swapping, so we get the 86 back again. We're now going to move ACC up, so we're going to move 86 up here. And now we're going to wait for this to do its thing. Meanwhile, you are moving left to ACC, so now it's preparing to do its thing again. All right, so you move down ACC. So you're going to take this number and move it into ACC. And then we have a bunch of no operations. And this is the hack. This is the hack that they're, the thread was talking about, which is it's just to wait. It's just a pause. And then we're going to move ACC left. So put the 86 in here. So we need to give these time to run. That's why that's in there. And now 86 gets stored inside of this stack. And if we notice, 86 is the largest of these. So this should be fine. Okay, so next up, 27 is about to go in here, which we notice basically what's happening is that these are saying, okay, you get to pass through here if you're larger, but if you're smaller, you get sort of saved in here, which works for a certain size of these. I think that if we get too many, it won't work anymore, but it solves the puzzle, which is enough for us. And then finally, let's go through until all of them get stored in. Oh, and then move ACC left. Oh, right, because over here, this moves it back over here. So basically it's just sending this in a loop, which is funny. But then if it goes through all of them and it thinks it's found the smallest, it then sends it out. So so let's see what happened there. Over here, we move ACC right, move ACC right. So that was the 15 right twice. And then we move right ACC. That was 15 back to here when it was the smallest. We save it, so we have both of them again, and we jump to pass. Pass is then just doing this entire thing again. We're just passing it along. If, however, it was ever equal to 0, then we just want to move whatever we had over to the right. So that would be the 15, because it was the smallest. Swap it, and then we move that down, because we have the smallest. So this one is always holding the smallest one at all times. And then that moves down, which this one just moves up down. It just sends it out, which is what we have in 15. For you, we already went through, okay, so we went through bigger. No, I think we went through smaller. So bigger is just the opposite. We move left up because this one's bigger. And then we want to send what we have there. So that way this always has the smallest one, which is it's a brilliant way to solve it. I mean, I think it's a pretty brilliant way to solve it the first try. I'm sure, like, obviously if you try to refactor over and over and over again, you're going to get even better and better and better ways, but this is pretty good. And I think this was the author's first pass to get it working. And first passes for anything. If you get it working, that's good. And so that's it. It should just run through now. And when it hits zeros, it then finishes and drains everything and sends them on through. So let's run this. Half the fun of this puzzle is watching all of the nodes do their thing, especially the stacks. And then we'll go into fast forward mode once we reach the end of these. All right, yeah, so that's all of those. We'll go fast forward mode. And here are the stats for it. So fun. And that's it. We had done all the other ones previously. We're skipping the net because those seem to be more like user created or basically bonus puzzles. We're not doing those. So we finished the core part of the game, which I think is great. So that is what I have.